Radioactive tracer techniques are used primarily to determine fluid movement into injection wells and to locate the placement of injected material, such as fracture propellant. The tracer may be added to the injected fluid at the surface or released downhole. For liquids, the most common radioactive isotope tag is iodine-131, introduced as sodium iodide dissolved in water. Iridium-192 is often used for tagging sand or propellant. The use of multiple radioactive materials within a single application has been developed in recent years. Typically, different isotopes are used to tag different materials, perhaps the fracturing fluid, lead-in sand and tail-in sand of a fracture treatment, and their relative placement is evaluated later using a spectral gamma-ray tool which can distinguish among the isotopes. The most common tracer technique detects the presence of channels behind pipe. Radioactive material is ejected from the tool into the injection flow stream above the perforations. The tool is lowered and the interval logged from the bottom to the top. The location of the ejected cloud of radioactivity is easily detected. The tool is again lowered and another log made while injection continues. With each repeated log, the movement of the isotope is monitored. If an upward channel exists, the isotope or part of it changes direction and begins to move uphole. Fracture height determinations are made by tagging the injected propellant and then comparing pre- and post-fracture gamma-ray logs to detect its location. A pre- and post-fracture temperature survey confirms the fracture location. The increase of radioactivity at the bottom of this interval is attributed to the settling of propellant in the rat hole. The apparent discrepancy between the temperature and tracer techniques at the bottom of the fractured interval may be caused by the responsiveness of the temperature survey to the gross fracture height through which the fluid moved, part of which apparently remains unpropped.